All right, so folks, we're going to take a look at the next one here. Nitrogen trioxide. This is actually a nitrate ion. Um, so let's go figure out how many electrons would make everybody happy. Well, we have one nitrogen. Nitrogen is happy with 8 valence electrons. We have 3 oxygen. The oxygen is happy with 8 valence electrons. So this is going to give us a total of 32. Still have one nitrogen. Nitrogen has 5 valence electrons. We still have 3 oxygens. Oxygen has 6 valence electrons. Those numbers, if you're curious, are coming from the group number: 15 for nitrogen, 16 for oxygen. Drop the 1 out in front, and then we're just left with 5 and 6. And then the negative 1 means that there's an extra electron floating around, so we're going to add 1. So this will give us 24. Now we're going to subtract 24 from 32, and this will give us 8. And there's 8 electrons that need to be shared. And since 2 electrons make up a bond, we need 4 bonds. We're going to put our nitrogen in the middle and surrounded by oxygens. Single bonds to everything. And that gives us 3 bonds, but we need 4. So we're just going to arbitrarily choose one of these other ones to be a double bond. So it doesn't matter if you did it over here or did it over here. It really wouldn't change much, with the exception of how many dots each of these oxygens gets. So this oxygen here that's attached to the double bond only needs 2 more electrons to make it happy, 2 from each of the bonds, plus those 2, and those 2 gives us a total of 8. This oxygen down here thinks it only has 2 from the bonds, so we need 6 more to give it its 8. And this oxygen would also need 6 more here. Because it's an ion, we've got to put the whole thing in brackets with a negative 1 on the outside to show that that's its charge. For our ABE notation, well, let's look at our nitrogen again. Nitrogen, this is happy, no more dots for this. 2, 4, 6, 8. 8 electrons it's attached to. So here, let's take a look at our ABE. We're going to use A to represent our central atom here. And then we're going to see how many atoms it's bound to. In this case, 3. Doesn't matter that there's a double bond. All I care about is how many atoms it's bound to. And then we look to see if there's any lone pair electrons in the central atom, and there are none. So now we're going to go figure out what our shape corresponds to. And if we look up AB3 on our cheat sheet, we find that it is trigonal planar. And then to find out if it's polar or not, we got to look at the different types of bonds that we have. We only have bonds between nitrogen and oxygen. Nitrogen has an electronegativity of 3.0. Oxygen has 3.5. So whatever your answer is, if it's negative, make it positive. And our difference is 0.5. 0.5 corresponds to polar bonds. I don't know how I just spelled that. Let's see. Polar bonds. So we go down our flow chart. First question, is there a polar bond? Yes. The answer is yes. So that means we might have a polar molecule. The next question is, do we have any lone pair electrons on our central atom? No. So therefore, that makes this whole thing nonpolar. So the compound itself is nonpolar. So what I'll do is just the next bunch on this page, I'll write up and then do a quick walkthrough, but with the answers already there for the next video.